Now problem 5 is an integral that can be solved with u substitution, but because the derivative of that inside function, which is x plus 1, because its derivative is 1, it really doesn't need to be done with u substitution. It's a simple case. And we can simply, in that case, when the derivative of the inside function is 1, can't be any other constant, has to be 1, we can simply find the antiderivative the way we normally would. That would be increasing the exponent, so we'd have x plus 1 to the fourth divided by 4, and integrate that from 0 to 3. So I can bring out the constant multiple of 1/4, and I would have 3 plus 1 to the fourth minus 0 plus 1 to the fourth. 0 plus 1 to the fourth is just 1 to the fourth, which is simply 1. 3 plus 1 to the fourth is 4 to the fourth power. And 4 to the fourth power, that would be 64 times 4, which is 256 minus 1. And we end up with 255 over 4, which is option D there. So I'll solve this using u substitution so you can see how it works. It's not necessary when the derivative of the inside function is 1, but it also works out to be pretty straightforward. We'll let u equal x plus 1. du then is dx. What we'll need to do is swap out limits of integration, though. When x is equal to 3, u would be 3 plus 1, or 4. When x is equal to 0, u would be 0 plus 1, which is 1. And so we now have a new integral from 1 to 4 of u to the third du, which would be 1/4 u to the fourth from 1 to 4. And you can see that that's going to be, I'll write it over here, 1/4 of 256 minus 1, or 255 over 4. So we still get the same answer when we do u substitution. Again, when the derivative of the inside function is 1, then you can treat it as if it's just x. But obviously you leave the x plus 1 there. Raise it to the fourth, divide by 4, and evaluate from 0 to 3. All right, we'll stop this one here.